2 times minus 3 all over 2 times 2.
Okay. And that bomb would, well, I guess we can simplify this further. So x equals minus 2 plus or minus 4 minus 8. 4 plus, was that 24? So it's the square root of 28, I think.
Yeah. Yep.
Okay.
Correct.
All under, or all over 4.
Yes.
Let me double check. So yeah, it looks like they have the same results. Same kind of results. All right, very well.
So there's your answer, but that's only part of it. Like
Mhm.
that's only x. Because there's 2 different x values, that means it hits the circle twice.
Yeah.
To find the y value, you go back and use this equation. You have to basically take each x. You have to say, okay, let's let x equal minus 1/2 plus square root 7 over 2. Y is equal to x plus 1, which means you're going to put this thing in into for x and add 1. So it becomes 1/2 plus square root of 7
Mhm.
over 2. And again, that's only one of them. So your ordered pair here is minus 1/2 plus square root of 7 over 2, comma 1/2 plus square root of 7 over 2. And then you do the same thing for the negative one. You let x equal the minus 1/2 minus square root 7 over 2. Basically just change that. Put it in here. It's the same thing though, except you switch the sign.
Okay.
Hopefully that's somewhat clear.
Yes.
They sure didn't do you any favors here
Yeah.
for this one.
Okay.
It's a good problem though, because you have to use quadratic formula. It's not nice, so you can't sort of like manipulate your way through it without actually doing it.
Yeah. Alrighty. Okay, that's helpful. Maybe question number 10.
All right, let me get back to that. 10. Okay, so yeah, sounds good. Right. So well, here's what I see. This is well, there's a couple ways to do it, I guess. Like one thing that I think is kind of obvious, when they're opposite in sign here, like you're kind of like looking at those that they will cancel when you add the equations together.
Mm-hmm.
But maybe you don't see that. I don't know if you do or not. And like the other thing I see is you could factor out a t subscript d from both on the left here.
Yes.
That's another way to do it. It really depends on what you see when you manipulate the equations. So what I'm trying to say is, like, if you were to then divide the equations, which you can do, the TD cancels and you can get B. That's one way to do it. Another way is to add them vertically. What do you see? I guess like we add them vertically, it becomes 2B TD equals 96.
96. Yeah, that's probably why I see.
Okay. And so if you divide by 2, you get BTD equals 48. And you're like, why would you do that? Because BTD is in the equation. Like you can put 48 back in. This is one of those things that you see on standardized tests all the time, where if you're comfortable not necessarily solving for the variable, either a sum of the variable or a product of two things, that
Yeah.
first equation becomes 48 plus 3 TD, and it's solved. I mean, you've only got one variable. You can do this. You subtract 48 from both sides. 3 TD equals 12. Divide by 3, you get TD, and then you use it back in this other equation for that as well. But if you and that gives you I think B is 16.
Yes. Okay.
Now you can also do that over here on the right, believe it or not, because when you divide the equations, the TDs cancel and you're left with B plus 3 over B minus 3 equals 60 over 36. You will get the same thing for B if you do it that way.
Alrighty. Sounds good. Okay. Um. Perhaps problem number 30.
Okay.
Similar to what we've done in the past, but
Yeah. You must have been like sick the week that this was taught in your school.
affirmative.
Okay. All right.
It's like to have refreshers.
All right. Find the equation of the line that passes through this point 7, 2 and is perpendicular to the line 4x minus 6y equals 25. So we've got to first take this given equation and we want to find its slope,
Okay.
which means you need to solve for y. So could you do that for us? Could you get the slope of this
Okay.
equation?
All right. Okay. So that will be y equals 2 third x minus 25 over 6.
Yeah, now you actually don't need the constant. You can actually ignore
Alrighty.
that. You can just cut it out. So the slope here is 2/3, but we want the perpendicular. So that if it was parallel, we would have the slope. The perpendicular, you have to opposite reciprocal or flip negate.
Yep.
Is that clear?
Yes.
All right, so once we get the slope, we're done. We're done with this equation. We don't need it anymore. We don't care about it anymore. You've told me a couple times now, you guys like y equals mx plus b
Yes.
format. Okay, so you've got the slope minus 3/2. That's going to go in for m. We have an x and a y. We can use that to solve for b. So we've got 2 equals minus 3/2x. X is 7 plus b. So you got to do a little fraction manipulation here. Minus 21/2. Now, whenever I see that the fraction, there's a fraction on the right, I change this number to have its common denominator on the
Yes.
left
So that can be
immediately.
added easier.
Much easier, yeah. And so this becomes 25/2.
Okay.
And that goes back into this equation, but you also need to include the slope, which is minus 3/2 x plus 25/2.
Cool. Alrighty. Very well. Also, like I understand the concept, but as the Latin saying goes, repetitio est mater memoriae. Repetition is the mother of memory. So it's like
It is. It
be
is.
refreshed, I guess. Anyways,
You can definitely do this type of problem, though. I mean, this is, if you can do the other ones, this is totally in your real world to be able to do.
yes. All right, I'm just looking for stuff that I might be a little bit challenged on. Okay, let me look at the first few. Okay. Problem number 3.
All right. The large jug contained 100 liters of a solution that was only 50% alcohol. How many liters of a 20% solution should be added to get a solution that is 23% alcohol? All right, so before we even work this out, is the answer more or less than 100 liters?
It will be more
Why?
because 23% is a lower, I guess, density than 50%.
Yeah, I mean, it's going to be probably a lot more because you're
Yes.
trying to get it. You're trying to get it closer to
20
20,
than
which
50.
means you need to put a lot in there, a lot in there. Okay, so the kind of the overarching equation here is percent times amount plus percent times amount equals percent times amount.
Hmm.
So it's 0.5 times 100 plus we don't know how much we're adding, so we'll call that X, equals our goal is 23%. The amount is X plus 100.
Gotcha. Okay.
This is, I mean, some ways you think, oh, it's a cheat. I mean, it's not. It's what these problems are. They're just percentage times amount problems.
Yeah.
Same with money. Do you want us to solve it?
Yes. So that
Okay.
will be 50. All right.
Nope, 20. I have 50. I misspoke
Yeah.
there.
Plus. Gotcha. Okay. And then produce, that's 27. Oops. Okay. So that's what, 0.9 or something? No, sorry. 900,
I,
right?
I can't
Oh,
remember. Are you allowed to use a calculator?
yes.
All right, please do. Please check me because
Gotcha.
I'm not getting a grade on this.
Yes. All righty. Very well.
And
Okay.
that shouldn't surprise. That's why I asked you that's why I asked you, this is like the reasonableness. You told me like, hey, you're gonna fly. I mean, it's like you have to know whether the answer is reasonable or not. Like, yeah, you need a whole lot more of this
Yeah.
bottom one than this one. And I mean, that's
Yeah.
just to help real life. It's like how many
Yeah.
pizzas do you need for a party? You gotta, do we need 500 or do we need five? It depends on.
Yeah. Kind of good to have analytical skills.
Yes.
Okay. All right. One of the newer ones would be problems like 12 and 13.
Okay. Do you want to try like 13 on your own before I jump in here?
Sure.
I mean, if you have questions, of course you should ask, but
All right. Sounds good. Let me copy it down. Okay. Okay. Is the answer something like x to the power of 3a plus 2 on this one?
okay, let's take a look here. So I would write x 2a plus 4 in the numerator.
Mm-hmm.
And then if I'm really doing it shortcut, I'm subtracting everything in the denominator like this.
Yes.
So it becomes plus 3a from the minus a, 4 minus 2 is 2. So yes, that is
Okay.
correct.
All right.
So the only difference with 12, I guess, is that there's more things going on, but you can only combine the top and bottom if there's the same base. So that again, probably be good for you to give this a try on your own
Okay.
here, and see what you come up with.
Very well. Yeah. For some reason, I was having trouble with these questions a couple lessons ago. So, all right. Let's see. Okay, with the x to a plus x with the power of a over 3, will I just divide both sides by 3 to add?
So think of it as 2a over 1 plus a over 3. You want to make a common denominator of 3. So it ends up being 6a over 3 plus a over 3.
Okay. 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 Is it going to be something like x equals 7 a divided by 3 plus or yeah, y equals 7a divided by 3, and then y 5 ba divided by 3.
Yes, there's no plus though. They're squeezed together, so they
Yeah, yeah,
multiply.
sorry. That was me misreading my own work. Okay, good, good, good. For some reason I was having a little bit of issues with those before, but that's good. All right. Let's see. Do you have any particular recommendations for ones that I think I need to work on?
I mean, I guess I would just ask, well, let me look here, see if there's ones that we've done. We should do 19, or you should try 19, I guess. And
Okay.
actually, before you try it, that's sorry. What I want to hear is your path here. What are you going to do to solve
Okay.
19? So don't just start doing it. Tell me what you're going
Okay.
to do and why. That's important.
Okay, so I would basically simplify the bottom one and make it solve for z. So I'd subtract 2x from both sides.
Add
Yeah.
7 to both sides. Yeah. Then it's already solved for, because it doesn't matter whether z equals 2x or 2x equals z. Those are the same. Okay, that's good. What will you do now with that?
Okay, right. Okay, so I'd substitute that into probably the first equation, I think.
And which other equation?
The second one.
So you seem a little uncertain. The reason you're doing that is you're getting rid of a variable. You're getting rid of z. Now
Mhm.
you're replacing it with 2x, but you already have an x, meaning
Okay.
you only have two variables. Same thing here. You're replacing z with 2x, multiplying it by -2, but you only have x
Yes.
and y. So you have two equations and two unknowns.
So I solve for x first, and then I'd basically simplify that into, I think,
You
bigger
solve it
equation.
using substitution or elimination, however you want. Why don't you
Okay.
work that out? I'm going to solve it using matrix with
Okay.
matrices, and we'll just compare answers here.
All right.
And if you want to check any of your answers, as you go, I've got it down for you here.
Okay. Solve for the equation.
Like, do you have a value for x or y you want to check?
Yeah. X equals 2y.
No, like x equals 5 or x
Oh,
equal like it actually.
no,
Okay,
I'm still working on that.
still working through it. Okay.
Let's see. y equals -3.
Yes, that is correct.
Okay.
Keep going.
X equals -2.
Issue on that one.
Let
X
me-
is, yeah, take one more look at that.
All right. Let's see. X.
So like I would use that first equation, like you said,
Okay.
X, you even said it. I think you said X equals 2y.
Yes.
So y is -3, X is 2
Let's see.
times -3.
All right. Just write that down. So that's gonna be X equals 6.
-6, 2 times -3.
-6. Oh, right. Sorry. Okay. So, and then we can solve it all for, let me put that down.
Get that last one for z, but you kind of already have it. Z is 2x.
Yeah. Okay. So Z is going to equal -12.
Yes.
Okay.
Got
All right.
it.
All right.
All right. So I would, if you're asking me, which you don't have to, but I would go to 20 and 21 next, because you've sort of said, hey, those are ones I don't
All right.
like.
Yeah, sure. That'd be helpful. Copy them down. Okay.
Now, are you allowed to use a calculator?
Yes.
So I've been drawing these, and you don't have to do that. You can actually just say X is -10 cosine -40 for the first one. Y is -10 sine -40 for the first one. Like you don't have to graph them. I'm not sure what I was thinking, but I was also trying to give you more information than
Yes.
that. Now the other ones are same thing, 10 cosine -220, 10 sine -220.
Oh,
And
yeah.
and
Gotcha.
that's it. Like you don't have to, you don't have to do anything more. You don't have to draw the picture. I apologize if I
Yeah.
got you kind of thinking these were harder than they actually were.
Okay. All right. Well, let's see. I'm just calculating that right now. Also, if you can hear like keyboard clicking or whatever, that's not that I'm distracted. It's because I'm using the calculator. So,
Yeah, no issues.
yep. 10 sine -2 pi. All right. Okay. So that's -15.32 R plus 12.86 Q, as they would put it.
Let me get going on. So I'm sorry, what was the first one for X?
-15.32.
Yeah. So how would you would actually do 15.32 R? I guess that's what you're saying.
Yeah.
Okay, good.
So what's
And
that really saying is left, basically, but
it really is. Yeah, it's an odd way of saying that.
uh
For me, it would be very confusing if we walked around the world doing
for me
that.
too.
Yeah. But that is what they do. What is the sorry, just to confirm, what's the second one?
12.86 CU.
Yeah.
Yep.
All right. For For the next one, I'm trying to think if there is a shortcut here to writing it in polar form. I guess you can think of this as X and Y. If you
Yeah.
really want to do it that way. So you can R squared is X squared plus Y squared. Sometimes it's just written this way, X squared plus Y squared, but you lose kind of the whether it's plus or minus, but that's taken care of with angle theta. Theta is the arctangent or tan inverse of Y over X.
Mhm. So that'd be basically pull out calculator, inverse of tangent. I'll just click that right now. Of minus 10 over minus 3 or just 10 over 3.
Yes.
Okay. Okay. So that is 73.30 basically, or 73.3.
For the angle.
Yes.
Getting caught up here. Yeah, 73.3. How about the R?
Okay, so then I think what my teacher would have us do is square both the X and Y.
Mhm.
And then, obviously put that put the square root of that, and then that is basically what we put next to it. So, it would be like 73.3, or sorry, no. It'd be the square root of everything that I was talking about, basically next to that angle 73.3. So
Yeah, I mean, you know if you can write it as square root 109 angle 73.3.
yeah,
I mean, why couldn't you write it then as square root 109 angle arctan 10 over 3?
yeah,
I don't know.
yeah. So
Uh,
I'm just looking at it. So it would be square root of 109 next to the angle 73.3.
yeah,
Gotcha. All right, very well.
26 is one that we've looked at in the past. If you're still asking me,
Okay. Yeah, sure.
all right.
I'm fine with whatever. Anything to help with the load later, I guess.
Yeah. So the first thing here is to move everything to one side. We're going to subtract the 6x from both sides. Minus 3x squared minus 6x minus 1 equals 0. This is kind of the form you expect this to be in. Step one here is to move that constant to the right side. And then I'm going to put in some boxes here. We need to fill in the boxes. Now, my approach here, which may be different than what you see in the classroom, is I do factor out that -3.
Okay.
Which is a little different than what you might see in the classroom. But the reason is most students are really comfortable completing the square on this, but not so comfortable with this. You turn something you don't like into something you do like, or at least something that's more familiar to you.
Okay.
So the next step here is to figure out, well, what goes down here in parentheses. It's half of this number. It's x plus 1 squared. And then what goes back here is the square of 1. And then what goes back in this red box is when you multiply n by -3. Now what you should notice here at some point is you'll realize like everything on the left is exactly the same. Like they all equal each other.
Yes.
And that's critical. It's like they're all the same. Yeah, they're all the same. So this on the right here equals -2. Okay, and you're going to solve using the square root property or square root method.
Okay.
Before you do that, you've got to divide by -3. So your book does you no favors. They don't like make this nice. They just keep hammering out
Yes.
little wrinkles, oh yeah, how do I do that? I mean, the average algebra student like would just crumble in this situation. So
Yeah.
it's a lot to ask you to do this. So here you got to take the square root of the top and the bottom.
Mm-hmm.
You have to rationalize the bottom here by multiplying by the square root of 3. So x equals, you're going to subtract 1 from both sides. Always stick that up in front. -1 plus or minus the square root of 6 over 3.
Gotcha. Alrighty. Very well. Okay, let's see. Okay, 27. That would be helpful.
Sure. All right, use unit multipliers to convert 40 square inches per minute to square yards per hour. So write the given number, 40 inches squared per minute. And our goal, sometimes it's good to write the goal over here, yards squared over hour, just so we know what we're going towards.
Okay.
And this is considered a double conversion. So you're either going to convert inches squared to yards squared first or minutes to hours. Don't do them at the same time. Just pick one, work on it, and then go back and work on the other. Which one do you want to work on first?
Perhaps inches to yards first.
All right, so there are 12 inches in 1 foot. Okay, but we have a problem here because we want inches squared. So we have to square both of these.
Okay.
And that if if that's uncomfortable, it's 1 foot squared over 144 inches squared. But the units have to cancel. You have to get inches squared, go away with inches squared. That's what you have to get here. And then but because we don't think in terms of squares, that's why I don't do it until the end. So there are 3 feet in 1 yard. But again, we want square yards, so we're going to square this.
Okay.
So again, that's down here. You want yards squared over 9 feet squared, like that. So we've got the yard squared. Great. Minutes. We know that there are 60 minutes in 1 hour, and that one's no multiplication thing needed. Okay, so you
Okay.
see you're down to your units here. You can enter in the calculator 40 times 1 divided by 12 in parentheses squared times 1 divided by 3 parentheses squared times 60, like that.
Okay. Okay. So that equals basically 200 over 3 or 66.66666 on to eternity.
I got something different here. 40 times.
Oh, I didn't square it. Silly me. Hold on. Okay. Give me a sec. Okay. My apologies. That's 50 over 27.
Yes.
Okay, which is 1.85.
Yes.
Gotcha.
Now you might want to ask the significant of square inches per minute, square yards per hour. I mean, that's just it's an odd unit.
A little
to
bit
think
weird.
about.
Maybe it's like I don't know. I know that tank designers have to basically spread out the weight as evenly as possible. So maybe that's sort of the idea
So
to
what you're referring to is a pressure of force per unit area, which is
yeah.
true. Absolutely, you want to do that. We do that all the time with our bodies. We spread out for balance.
Hmm.
Yeah.
Gotcha. Alrighty. Or like you'll notice that bigger planes tend to have more tires, like the explain ever the Antonov AN 225. I was like, what, I think 32 tires or something like that.
Yeah.
So and they're huge too.
Yeah, it's kind of neat that you fill up a tire full of air and you can lift a lot of weight, with like a
Yeah.
hand truck. It's kind of neat.
Yeah, exactly. Alrighty.
All right, what else can we do tonight?
Hmm. Okay. It's kind of weird because these problems, these next ones I'm going to talk about appeared in Algebra 1, but apparently they're back 2/3 of the school year all of a sudden, which is weird. But so I guess problem 7, 8, 9, they're all pretty similar. I mean, just one to solve. Like it's not like they all need to be solved specifically, but those three are pretty similar. I like
Yeah, I
to see
wasn't
one of
wasn't
them.
sure we asked for these because these are I might have some questions on this, but the let's first focus on the domain of number 7. The
Uh,
domain is the negative integer, so that's dot 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 -6 -4 -2. That's your domain. Would you agree with that?
yes.
Okay, but we're saying that x has to be not, okay, let's just say it was x was less than or equal to -2. Let's say it was this instead, x less than or equal to -2, and
Okay.
it was the negative integer. So this would then be dot 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 -6 -4 -2. Would
Hmm.
you agree with that?
Yes. Yes.
Okay, but since it's not, it's everything else.
So it's basically all above that.
Yeah, it's
So
nothing. It's the empty set, or
yeah,
there is nothing.
yeah. Okay. Well, there's lovely. So just nothing. Cannot compute. Crash
Well,
the four worlds of the internet.
yeah, it's a weird thing. You could talk about these. These have some interesting properties, I guess, if you like this stuff. But um, the thing is to focus on what are what is the domain.
Hmm.
And actually, we should do 9 next because it's more similar. So again, negative integers. We know what that is. That's up here. We need to add 6 to both sides.
Okay.
Okay, so then -x 3. Now, this is one of those things they don't show you, but if you like, I don't want to handle that symbol because I'm just going to add x and subtract 3. So I
Okay.
get x on the right here and then rewrite it. So x is less than or equal to -3.
Hmm.
So if the domain is negative integers, that's everything up to -4. That's good. But since it's the slash,
Hmm.
we don't want those. We just want now the one that's left out, which is -2.
-2. Yeah.
So what I'm seeing here, and this might be something to keep in mind if you get a problem like some test quizzes, is like it's usually just a number, maybe 1 or 2 numbers, maybe it's nothing, empty set.
All right.
All right, now the middle one, yeah, I couldn't tell you why this is coming up again. I mean, domain and range are important. Maybe that's why
Yeah.
you'll see that here, some graphs or something
Maybe.
you're doing. So -3 -3 -x, and I'm doing it this way where I
Hmm.
get rid of that symbol for the moment. And then just because I don't want to deal with flipping and wondering how that affects this, I'm just going to add. So it becomes 1 like this, x is less than 1. So it's all the numbers that are less than 1. So on the number line, there's 1. It's everything to the left of that. But the not means I'm going the other direction.
And it would also include one, right?
Exactly. Yeah. All of a sudden it's included there.
Gotcha. All righty. Interesting. All righty. Well, I'd say we've done for maybe one more question.
Sure. Yep.
About like 80 why do I keep on reading the numbers I need? 15 or 16, sorry.
Okay. Yeah. I mean, they're the same. I'll do 15.
All right.
All right. So you're going to multiply by what's called the conjugate. And the conjugate is exactly what's on the bottom, except you flip the operator in between. So if it's plus, it becomes a minus. If there were a minus here, it become a plus. But you multiply the top and the bottom by the conjugate. We're going to focus on the bottom first because that's the one where the kind of the magic happens here. You're going to FOIL. So minus 5 times minus 5 is 25. Then you get plus 5i minus 5i minus I squared. You should notice right away that the i's cancel.
Yes.
Okay, so and then I squared is -1. So the bottom becomes 25 minus a -1, or it becomes 26.
Yes.
The top, you have to do the same thing. You have to FOIL. So you get -10 minus 2i plus 15i plus 3i squared. The top does not cancel. You combine like terms. You've got -10 plus 3 times -1 for the I squared, the constant, and then you got minus 2i plus 15i, so that's 13i. I don't recommend trying to do too much at one time here. Get that framed better in case you want to get that down. Okay, so it's minus 13 minus 13 plus 13i over 26. You divide each of them by 26, so it's minus 1/2 plus 1/2 I.
Okay. Gotcha. All right. Lovely. Okay. I think that's all for now.
All right, awesome.
Yep.
Stop the recording.